Okay, so for this question, we're given f of x and g of x as 1 over x, and we're asked to sketch f of x minus g of x. Now, whenever we're given difference of two functions, the way I like to think about it is by doing f of x plus negative g of x. So essentially what we're going to do is we're going to sketch the negative of g of x, and then we're going to do addition of ordinates. And the reason for this is because addition of ordinates is much easier than subtraction. So what we'll do is when we sketch g of x, we'll actually sketch, instead of positive 1 over x, we'll actually sketch negative 1 over x. And that's going to look something like this. We'll do it in dotted line to signify it's one of the parts of the function, but not our final function. The other line we have is y equal x. That's just a vertical line like this. Now from here, what we'll do is we'll do addition of ordinates. So this is negative g of x. This is f of x. Now, the interesting thing about g of x is that we have asymptotic behavior at 4 different points. So we have to take this into consideration when sketching the addition of the ordinates. So when we start from negative infinity, which is approximately there, we have a very small value for negative g of x, but it's not exactly 0. So that causes the asymptotic behavior. But when we do the addition of the ordinates, we're adding a very small value to f of x. So at this point, or negative infinity, we're going to have a very small value, something like that. So it's going to asymptote from that line, and then it's going to intersect somewhere on the x-axis. We can see when we do addition of ordinates, when we have an approximate distance on either side of the x-axis, that's when it crosses. That's when it creates an x-intercept. Now from intuition, I know that at x is equal to negative 1, this point will be 1, and this point will be negative 1. We can double check that just by looking at the original functions. So I know at x equals negative 1, we're going to have the x-intercept. Then the same thing happens as we approach 0. We get a very small value here, and we approach infinity as we go upwards. So that's going to asymptote towards that line as well. Now on the other side, on the right-hand side of the y-axis, is a very similar case. We have asymptotic behavior starting from here. We have an x-intercept at x equals equal to 1, and then we asymptote towards here because the y value is approaching 0. So this value will be x is equal to 1, this value will be x is equal to negative 1, and that's our addition of ordinates done.